Hello. Today we'll continue with logic. We'll start with implication. If the first variable is true, we expect the second to also be true. The first one is called the antecedent, and the second one is called the consequent. If the antecedent is false, we don't care about the consequent. This might confuse you, so let's see an example. If it rains, the road is wet. We expect the whole sentence to be true if it rains and the road is wet. But if it's not raining, the road may be wet because of other reasons, like someone was watering their garden and the water went to the street. The implication goes one direction. Since Godot doesn't have a keyword for this, we'll see an equivalent form. If the antecedent is false, the implication is true. It is also true if the consequent is true. So it is not P or Q. So let's use this one, not P or Q. True, false. This is the only case where we get false. And there it is. Oh, I forgot the button. Let's just hide it for now. Okay, now what if we want implication that goes both ways? That is called biconditional. This time we check if two sentences have the same state. Now for the biconditional, we have an operator. Equals equals returns true if both values are the same. That's what we want. We also call this one XNOR. It's the opposite of XOR. We'll see this later. P equals Q. False, since they're different. If they're the same, returns true. There's also the opposite, the XOR gate. It stands for exclusive OR and returns true if exactly one of them is true, or simply if they are opposite of each other. That one will be the not equals. It checks if they're different. Here's the description. That's the XOR. XNOR is short for not XOR. So we can also have NAND, which is not AND. And NOR for not OR. The NAND gate returns true if at least one of them is false. In code we write not P and Q, we use parentheses. And this is NAND. It's false if both are true. Here. Now let's talk about the De Morgan theorem. It moves the not inside the parentheses, giving it to every variable, and then it swaps AND with OR, and vice versa. If we have two nots, they cancel each other out. So we place not on every variable, change AND to an OR, okay, and we get the same thing. Now for the NOR gate, it returns true if both are false. So we write not outside the parentheses. It's true if both are false. Again, De Morgan, not on variables, change OR to an AND. Okay, finally the inequality operators. I'll use the ternary again, and we'll print the one that is true if they're not equal. Okay, if they're equal, print equals. else if P and not Q, print P, else Q. It prints Q since P is false. For this operator, imagine that true is always greater than false. So we can replace this with P greater than Q. It's the same thing. If we run it, same results. And now we get P. And if both are false, they're equals. Now, why did I include this instead of keeping it simple? This says P is true, Q is false. But we already know that they're not equals. Otherwise, we get the first case. That means if P is true, we know that Q is false. We don't have to check its value. So now we get equals. Now P. This might seem confusing, so let's show it inside a normal if. If this is true, we go inside. Now we know that P and Q have the same value. Because of the above line, if P is true, then Q has to be true. If P is false, Q is false. In other words, we can only check P. Q will have the same value as P. You can imagine this as if P equals Q and P. Now the else is the opposite. That means if P is false, Q is true. P is true, Q is false. True or false is always true, so we don't even need this if. It would always be executed. Okay, let's see the last two operators in simpler codes. P greater than Q true. That means that P is true and Q is false. Less false. Let's swap. And now it's true. And we're about done with booleans. In the next video we'll see a bit about loops and how we can use booleans inside the loop. So till next time.